Hey, good evening, and welcome once again to Meteorology Lab. It's another hazy day here. We've got the dust coming in from the Sahara by way of the Caribbean and southern Atlantic, or I should say the southern part of the North Atlantic. And it's given things kind of a silvery tinge, and you can see you can't quite see all the way to the horizon. Looks like that visibility caps out there at about 3 miles. And here's the surface chart. This is showing the dew point in green, and you can see a lot of the better moisture has worked up to the north, and back behind it some drier air in Texas. So the higher dew points running from about Oklahoma City up to Kansas and up to Iowa. I did want to mention we've got a small cloud identification test, so hopefully y'all have grabbed a pencil, something to write with, and I'll give you about 30 seconds to a minute before we get started on that. And let me just check in real quick on chat, make sure no disasters with the feed, and we're looking good. Okay. And just give you a very quick run through before we get into that cloud identification test. Let's look at the surface chart. We've got northerly winds in Kansas, northeasterly up in the Omaha area, and that kind of outlines the front extending all the way from Kansas City down to Dalhart and back up towards Raton and into the mountains of New Mexico and Colorado. Do we have a warm front? Yeah, I think we do. It's going to be right in this area here, southern Missouri. In fact, I'm going to need to recenter this. Stretch this out a little bit. And we see things a little bit complicated with the outflow boundaries. See, down to the south we got temperatures in the low 90s, and once you get up to Oklahoma City, Tulsa, temperatures drop off to 70. So it looks like in between we've got a little outflow boundary, kind of like that. And then our main warm front probably up there in Missouri like that, and then of course the cold front extending southwestward. Do we have a dry line? I don't think so. It's we see the moisture field fall off very gradually from east to west. So I'm not really sure I can identify exactly where a dry line is. You might be able to place one somewhere in there. Yeah, I would probably go with a weak dry line out there in West Texas. And let me show you what I'm looking at. See that 62 there at Fort Stockton, strong southwesterly winds. That could be conducive to strong thunderstorms there, especially in the spring when we see that. And then we see the moisture fall off to the 50s in Midland and 53 at Amarillo. So that appears to be the dividing line right there. Some low to mid 60s out around Big Spring, and then 50s out to the west. Okay, the cloud identification test. Let me see if everybody is ready. Funwood Tech, Chris Tyne, Shirley Keast here, and Christian Flock reporting stormy in Yukon. Okay, so let's bring up that test here. And this is an example of what you might see. And I just want you to just write down very quickly with an abbreviation what kind of cloud it is. So you might put CU for cumulus. And make sure you put the number that's going to be in the top left. So there's going to be 10 of these, each one 15 seconds. All right, so we ready? So all we're looking for is the cloud type. And here we go. we're finished. That's just one last look from frame number 10. So hopefully y'all did pretty well. I know that went pretty quickly, but we'll do more of these in the future, and you'll get some practice. So you ready for the answers? Let's bring up the answers. Here we go. Let me bring down the sound just a little bit here. All right, yeah, there's the cumulus. There's the example. Okay, this one. This is going to be altocumulus. You can see a little bit of opacity. They're kind of thick on the bottoms. You can see a little bit of shading. So this is going to be altocumulus up there at about 7,000 or 8,000. This one you can see a whole lot of shading, very thick, and this is definitely a lower cloud. So this is going to be stratocumulus. The bases on these probably about 4,000. For this one, this is actually towering cumulus or cumulonimbus. You don't often see underneath the base. You know, usually the cloud charts have it from the side. This is underneath. Number 4, this is going to be cirrus. We're looking for that cloud at the very top left, kind of covering most of the frame. It's almost cirrostratus. I would probably accept that there. It's got very fibrous appearance. Number 5, once again, altocumulus. You can see a lot of shading underneath. But this could also be stratocumulus. I wasn't really able to figure out which one it was. It could be one, could be the other. 6 is going to be altocumulus again. Up there at the top left, there's no shading. So this is a pretty high specimen of altocumulus. It's not cirrus because it doesn't have much of a fibrous look. 7, this is classic sheaves of cirrus. Kind of thick, so this is going to be high cloud 2. So we're going to be looking for cirrus for this one. For number 8, that's pretty thick, kind of smooth. That's going to be stratus. This is associated with a low-level jet here. I would accept stratocumulus. And then for number 9, featureless gray. It's got a very wet look. This is nimbostratus, or altostratus. I think either one would work there. And then number 10, this is a side profile of a small cumulonimbus cloud or towering cumulus. Just a very slightest hint of glaciation at the top, but overall these are super cool tops on these clouds here. So that is the test, so hopefully y'all did well. All right, and this is pretty important because as we look at satellite especially, those cloud types are very important because, you know, usually, let me bring up an example here. Let me get a closer example. Let's take the Oklahoma storms. Now, cloud type is how we go about identifying stuff on the satellite. It's kind of interesting, you know, as we get into all this high-tech meteorology, especially ASOS has moved away from cloud types, and that's almost kind of an afterthought. But cloud types are very much what we use for identification on satellites. So, for example, this is obviously cumulonimbus right here, and then right in here we see either cirrus or smoke. That would be from those Canadian fires. And then out here we see kind of a flatter look. This is either altocumulus or stratocumulus. So maybe we should have a little bit more emphasis on cloud types as we look at these images. I'll try to throw in some examples here or there. Anyway, yeah, there's the storms. Whoa, too fast. There's the storms there in Oklahoma. And let's run that back earlier, see what that looked like around late morning. So Oklahoma City located right here, Tulsa's up in this area, and we see kind of a very congested look. There's a lot of cirrus debris across the northern half of the state, and then down to the south we see low cloud fields out here. And that's kind of divided into two main types. See here, this is more transverse banding. It's got kind of a squashed look. This is stratocumulus. And there's the symbol for stratocumulus. And then out here we've got cumulus. It's more vertical, and it's, I guess we could say it's pretty much cloud streets. And that's pretty much what we would expect our storms to be developing from, is this stuff right here. This activity here is a little bit more capped, and this is probably due to outflow covering the southern part of the state earlier today. So let's see. Yep, there's the storms right there developing pretty close to that interface between the transverse bands and the cumulus out to the west. And there's our first cell. That's going to be about 130. That looks like it developed right over the Yukon area and moves in Oklahoma City, and then more storms up towards Mulhall and what are the others? Guthrie up to Stillwater. And then many more storms up in western Oklahoma. Looks like the atmosphere is not too well capped. There's also storms in the New York area, upper level low spinning across the Binghamton area. And this is kind of a repeat of what we had yesterday, where we had cold core convection across southwestern Pennsylvania, and that's moved on up towards upstate New York. And southeast U.S. still getting some storms in the southern part of that region, from about Montgomery down to Tallahassee and Jacksonville. And these storms are fairly well sheared, putting out good anvils spreading towards the south, and the cells themselves are not moving very much. You can see a lot of dry air has been moving through that area with that northerly flow coming in, and we'll check out the rest of that on the surface charts. I guess we can do that right now. Let's bring that up. You can see the lighter shading out there in the Appalachians. There's that dry air there. And then much of the moisture across Missouri and Iowa. So two different regimes there. There's that northerly flow bringing the dry air southward, and then in Texas and Kansas, Oklahoma, on the other side of that high, bringing the moisture northward. Okay, let's get into our chart sequence, and let's see, we've already gone through some of this. Upper air chart up at jet stream level shows the jet still way up to the north. There's our closed low over Pennsylvania this morning, closed low over Kansas, that's moved up to the northeast a little bit, and then a pretty good trough coming into Montana. So the most active area usually falls to the east of these upper level lows. So New York, eastern Pennsylvania, Kansas, all of them getting quite a bit of shower activity. All right, let's see here. I'm trying to figure out what to show next. Yeah, there's the thickness chart. Let's put the fronts up on this. Cold front edging through central British Columbia into northern Alberta there. Warm front like that. And then we've got another cold front coming in through the Great Lakes area. And then down to the south, you can see these upper level lows are kind of sitting out in the tropical air. We've got that one upper level low right there, another one over Kansas, and we're not seeing any very organized synoptic scale cold air masses. There are some thermal gradients in here, but obviously not a very well developed cold air mass to the north of either of those systems. And then this is our precipitable water, showing the highest values from Kansas into Missouri. You can see that very long fetch of moisture coming in from the Caribbean. And I did a trajectory plot for Dallas-Fort Worth there to see where the air masses are coming from. And this is how things looked right there. Pretty much all the air coming from the Central Gulf, coming onshore into Corpus Christi. This is the surface through 3 kilometers. This is up to about 10,000 feet. And let's go to the upper levels. We don't do that too often. It's got kind of a southwest to westerly origin. So the upper levels coming from the southwest deserts. And that can be a source of instability there, especially if the flow is more northwesterly. If the upper levels are coming in from the north, that can invite cold air southward. Meanwhile, in the low levels, you've got warm, moist air coming in from the south. So that creates something called differential advection. And that gives us, in the example that I've shown you, that would give us a cold over warm situation, which is unstable. So that's one reason northwesterly flow situations can be so potent, because of the destabilization from cold air aloft reacting with warm low-level air. So that's something to look for when we get into northwesterly flow once again. Okay, soundings. Let's look at soundings. Fort Worth. Okay, this is this morning at Fort Worth. Let me see if I can bring up the current sounding. I don't want to look at data that's 12 hours old unless we really have to, so let's bring up the current data. And yeah, this is a little bit better. So Fort Worth showing a little bit of a cap there up at 800 millibars. That's going to be about 6,000 feet. So this gives us kind of a very mild loaded gun sounding. You can see the moisture right there in the low levels. You can see the cap right there. Some dry air within the cap layer. And then above it looks like a little bit of moisture in the 10 to 14,000 foot range. So a little bit of alticumulus potential in that layer right there. Oklahoma City, that's probably going to be affected by those storms in that area. So yeah, a little bit messy there. We can see what the profiles look like earlier this morning in Oklahoma City. So not so much of a loaded gun sounding, but there is some dry air up above 10,000 feet. Some moderate lapse rates from the surface up to about 18,000 there. And only a small amount of shear being indicated right there. The flow is kind of unidirectional, southwesterly from 25 up to 50 knots there. So the storms are not going to be very well ventilated there in Oklahoma City. So that'll preclude some of the severe potential. And then just a recap of tonight's weather. This is the satellite loop showing that big upper level low dominating the picture. Looks like that's centered right around Topeka, Kansas. There's the center of that low. And we've got that other low up there in the northeast. Looks like that's centered right around Syracuse. And out to the west. Pretty quiet out west except for the monsoon, infiltrating much of northern Arizona, southern Utah, and central Nevada. And looks like a little bit of smoke hanging around out in the Portland area. Let's push that. There we go. Yeah, that's probably some smoke that's just been kind of recirculated through that area. And then there's the marine layer hanging off the California and Oregon coast. So let's go into the forecast. For our area here, looks like the model picking up on those cells there in Oklahoma. Those will probably organize a bit and move through the Tulsa area this evening as an MCS. into northwest Arkansas. And then those should start falling apart around dawn, as they usually do. Just a little bit of activity up there in the Ozarks. We're going to expect to see a lot of that precip move into the Midwest tomorrow. Let's run this up to tomorrow evening. Looks like a little bit of convective activity up in northwestern Indiana there. And then if we go forward another day into Thursday, looks like a lot of our activity will be up in Ohio, the Detroit area, and then for Friday it moves into New York. So that'll be the very gradual progression of that upper level low as it tracks into the northeast. And then we should see things drying out in the central and western U.S. And the reason I can see that, I'm looking at the thickness, which is these red lines. It's painting out a ridge, a very broad ridge, centered on the Four Corners and the Rockies right there. So that's going to put much of the Central Plains under a very light northwesterly flow. Not enough to really help us as far as thunderstorms, but the upper level ridge is going to be close enough to where we should see things start heating up a little bit. And let's look at the upper level patterns. There's the 500 millibar chart. You can see those lows moving eastward, and then another one drops into the northern plains. That'll affect mostly the Midwest around Friday and Saturday. One trough coming across the northern states, kind of cutting into that ridge right there. And then we see the subtropical ridge really starting to build early next week. This is a big high there. We're expecting temperatures to really start increasing in Arizona, the Four Corners area for next week. And that will affect California too. So looks like around midweek, maybe about a week from now, that heat is really going to be in full effect in Southern California, Arizona, and Nevada. This one does have some potential. See, we do have northwesterly flow in Texas, Oklahoma, and Kansas, and it looks like this trough may be strong enough around midweek next week to give us a chance of storms. That right there, let's see how far south that reaches. Yep, that comes all the way down to Texas, so we're going to see probably precip chances going up around Thursday next week. Wednesday and a Thursday. But back in behind it, big ridge back in there that's going to probably keep things kind of hot for the remainder of the week. And let's see, the next big change, that's pretty much going to be it there. Just looks like most of these will be affecting the northern tier states of the U.S. Okay, let me just check in on chat real quick. Erica Baker, Coffeyville, Kansas, 77 over 73. Got that moisture way up there. I appreciate that, Erica. Shirley Keast, about 7:09 p.m. That was probably doing the test there, and Sue M. joining us. Shirley Keast got 7 right. Fun with Tech, 6. And I would say anything over 5 to 6 is pretty good because, you know, I didn't cherry pick those examples. They were just kind of random. So they're not very textbook. They are challenging. And I would, you know, anything over 5 or 6 is pretty good. And I would say 7 to 8 would be an expert. Ryan Toomey's good you made it in. Mr. Manlet also with us, and Electric Dog. Almost missed it. All right. I think that's it for me. It's about dinner time, so I'm going to head on out, and hope you all have a good evening. Take care, and we will see you tomorrow. Bye-bye.